Hi everyone, here is a graphic organizer for you to help out with trying to figure out when to use which type of factoring technique. When you start factoring, you always want to check for a GCF. That's your first thing that you want to do. So always check to see if you can divide all the terms by a number, or to see if all of the terms have a variable in common. Then after you do that, you're going to want to count how many terms that you have, and that's going to also help you decide on which technique to use. So you're either going to have two terms. Remember, terms are separated by addition or subtraction, or you may have three terms, or you may have four terms. That's all you have to worry about in Algebra 2, is up to 4 terms. So if you have 2 terms, then one thing that you can try to do is called difference of 2 squares. This only works if you have perfect squares. So perfect squares would be like 1, 4, 9, 16, 25, and so forth. Perfect square variables would be like x squared, x to the 4th, x to the 6th. Those are all perfect squares. With the variables, when you take the square root, all you have to do is divide the exponent by 2. So if you have perfect squares and it's a difference of 2 squares, meaning it has to be subtraction, then you're going to use this formula: a plus b, a minus b. So for example, let's say that we had 25x squared minus 16. First, check for a GCF. Alright, I don't have a GCF between these two. I can only divide them by 1, and I don't have an x in both of these. But I do notice that 25, x squared, and 6 are all perfect squares. So I can make 2 sets of parentheses. One gets a plus sign, one gets a minus sign, and then we do our difference of 2 squares formula. So we take the square root of 25, which is 5, and the square root of x squared, which is x. We put that in the front in both parentheses. And then we take the square root of 16, which is 4, and that goes in the back of both parentheses. And that's factored. So that's difference of 2 squares. Now let's say you don't have perfect squares. Maybe there's another possibility for what you have, and that would be perfect cubes. So cubes are numbers that, when you take the cube root of them, give you a whole number. So perfect cubes would be something like 1, 8, 27, 64, and so forth. Those are all perfect cubes. And then for variables, it would be x cubed. This is the most popular one. Or you could have x to the 6th or x to the 9th. Basically, multiples of 3 for the exponent. When you take the cube root for a variable, you just divide the exponent by 3. So this has 2 possibilities. If you have a sum of 2 cubes, you're going to have little parentheses and big parentheses, and the signs are going to go plus, minus, plus. If you have a difference of 2 cubes, then you're going to have little parentheses and big parentheses, and it's going to go minus, plus, plus, like that. To get the terms that go inside, you take the cube root of each one of your terms. So that would be a for the front term, and we'll call this the second term b for the cube root of that. And then you're going to square a, multiply a times b, and then square b. And you'll have the exact same thing for the second set of parentheses. The signs are just different. So the cube root, which would be a, cube root, which is b, and then you're going to square a, multiply a times b, and square b. Now, this makes a whole lot more sense if I do an example. So for instance, let's say you had x cubed plus 8. So you check for a GCF. I do not have a GCF. X cubed is not a perfect square, and neither is 8. So I'm going to check for cubes. 8 is a perfect cube, and so is x cubed. Since this is plus, this is a sum of 2 cubes, you're going to make little parentheses and big parentheses, and the signs are going to go plus, minus, plus. If you can remember the signs, that's going to help you a lot on a multiple choice test because you can eliminate all the answers that don't go with this pattern. So now, to get this term right here, you take the cube root of what's in front. So the cube root of x cubed is x. To get this term right here, you take the cube root of what's in back, which is 2. Now we're going to square, multiply, square. So you're going to square this term in the little parentheses, x squared. Then you're going to multiply these two numbers, which is 2x. And then you're going to square the number in the back. 2 squared is 4. And that's it. That's factored. There's nothing else you can do with that. Let's try another example. Excuse me. So let's say we have x cubed minus, and let's do another perfect cube, like 125. Okay, so we check for a GCF. I don't have a GCF, but these are perfect cubes. We can take the cube root of 125. So we're going to do little parentheses and big parentheses. And since this is subtraction, the signs are going to go minus, plus, plus. So we take the cube root of x cubed, which is x, then take the cube root of 125, which is 5. By the way, if you need to do cube root in your calculator and you can't remember how to do that, you go to math and then choice number 4. Okay? Okay, so back to this. To get this term right here, you're going to square this x, so x squared. Then you're going to multiply 5x, and then you're going to square the back term, which is 25. And that's completed. Now, if you have 3 terms, then we need to do another method. Excuse me. This method is trinomial method. So, trinomial method is the one that has the m and the a. Okay? So, you always check for a GCF, and then after that, go ahead and do trinomial method if possible. So, here's an example of how that works. Let's do something like 2x squared plus 6x plus 4. So, I notice I have 3 terms. I want to check for my GCF though. Maybe if I can take out a GCF, I'll have some smaller numbers, and this M and A process will be a lot easier for me. So I notice that I can take a GCF out of all 3 of these terms. I can take out a 2. So I write that 2 down. I make parentheses. What times 2 gives you 2x squared? X squared. Plus, what times 2 gives you 6x? 3x. And then what times 2 gives you 4? 2. So now I'm going to cover this 2 up. It's going to be part of my final answer, but I really don't need to do anything more with it. So I'm just going to cover it up so I don't look at it anymore. And I have 3 terms. I'm going to try to do trinomial method. So you take the number that's in the front, which happens to be a 1 this time, and you multiply it by the number at the end, which is 2. We need to think of numbers that multiply to 2 and add up to 3. Well, that one's not bad. It's going to be 2 and 1. So we scratch out the 3. We don't need that anymore. Bring down the x squared. Now, instead of rewriting the 3x, we're going to use the 2 and the 1. And we're going to put an x behind each one. So plus 2x plus 1x plus 2. Now, you can write this in any order in the middle. It doesn't matter. It'll work out either way. So now we have 1, 2, 3, 4, which is actually our last technique for grouping. Or I'm sorry, it's called grouping. It's our last technique for factoring. And you're going to take a GCF between the first 2 and a GCF out of the second 2. So the GCF between the first 2 here is an x. You're left with x plus 2. Bring down the plus sign. The GCF between these 2 is 1. And you're left with x plus 2. And then since these match, that's a good sign. Our answer is x plus 2 times x plus 1. We take the terms that are on the outside and create another set of parentheses with a factor in it. Don't forget that 2 that we had out in the front. That comes down and is also part of our answer. That's completely factored now using trinomial method, and we use GCF. Now we can do one more type, which we kind of did down here, but I'll do another example for you. If you have 4 terms from the very beginning, we can do a type of factoring called grouping. And we just finished this last one up with grouping, but let's do one more example just so that we have one. Okay, and how about I give you this: 6x squared plus 2x plus 21x plus 7. So you have 4 terms. We should check for a GCF first, and then after that go ahead and do our grouping. So it doesn't look like there's a number that we can divide all these by, and they don't all have a variable either. This 7's missing a variable, so I can't take out any GCF. So I'm going to group these two, and I'm going to group these two, and I'm going to just look at them, like I'm going to cover this one up and just look at them as 2 at a time and figure out what the GCF would be. So if I look at these two, the GCF is 2x, and then we make the parentheses. What times 2x gives you 6x squared? 3x. What times 2x gives you 2x plus 1. Then bring down this plus sign, take out the GCF here, so it's going to be 7. Let's see if I can squeeze it all in here. I don't have very much space left, but I'm going to try. So what times 7 gives you 21x? 3x. And then what times 7 gives you 7? Plus 1. I just squeezed it in there. So look, these match. That's a good thing. That means we're doing this correctly. So you bring down 2 sets of parentheses. In one set of parentheses is 3x plus 1. And in the other set of parentheses are these outside terms, 2x plus 7. And that's completely factored using grouping. So there's basically a graphic organizer for you so that you can kind of sort out all the different ways to factor, and hopefully this helps you make some decisions when you're working on them by yourself.